Okay, we're going to look at the second part of 1.4 and 1.5 that deals with average rate of change. I've also worked some problems in your math lab assignment. Recall the different forms of linear equations. You have slope-intercept form where m, the coefficient of x, is the number, is your slope, and then your y-intercept in ordered pair form is 0b. You also have standard form. This is a shortcut for you to find your slope without having to convert this to slope-intercept form. Negative a over b, so the opposite of the number in front of x over the number in front of y, or their coefficients. Your y-intercept, you would actually plug in 0 for x, so this would go away. You would solve by equals c for y, so that, and then of course you would have to divide c by b. So that's where this comes from in ordered pair form. Looks like this. General form is one that you're probably not too familiar with, but general form is very similar to standard, but it makes sure that the entire equation is always set equal to 0. So it's always equal to 0, meaning everything else is always on the other side. And your slope is still the same for standard form as it is general. Negative a over b, the opposite of the coefficient or number in front of x, over the number in front of y. Your y-intercept is different, however. You would actually take this, by plus c equals 0, and you would have to subtract c and then divide by b to solve for y. If they're asking you to convert from general form, standard form, to slope-intercept, you just simply find your slope, find your y-intercept, plug in for m and b. Point slope form is actually the formula that they use to write equations of lines, which I'm sure you've already noticed if you've looked at your other set of notes and your other video. And to me, if they ask you to leave it in point slope form, this is the easiest, because all you have to do is plug in your slope for m, plug in a point on the line for x1, y1, and leave it. You don't even have to simplify it any further. Okay, I'm going to work out a few problems that's in your math lab with you dealing with slope. This is just a different way. They give you variable values instead of actual values. So this is just like number 1 in your math lab. You're given this point negative a 0, this point 0 negative b. They ask you to find the slope between those 2 points. So you would plug in y2. So you're going to plug this into the slope formula, which is here. I always let my first point be x1, y1, second x2, y2. It really doesn't matter as long as you subtract your y's on top and your x's on the bottom in the same order. Like for example, if I say my y2, which is negative b minus 0, then I have to subtract my x's in that same order and say 0 minus negative a. So this simplifies to negative b over a, and that's it. Next problem is number 2 on Math Lab. You're finding the slope between these 2 points, so you plug into the slope formula. y2 is b minus c minus y1, which is b. This simplifies. You got b minus b, that goes away, so you're left with negative c. On the bottom, x2 minus x1, so a minus a comes out to 0. And you can't divide by 0. Anytime you have 0 in the denominator, it's always undefined, and it will always indicate that these 2 points are on the vertical line. If you have 0 in the numerator, that would actually be 0. So your answer in that case would be 0. This would indicate that those points lie on the horizontal line. So please be careful, because people miss these type of problems. When they get 0 on the bottom, they want to say it is 0. Your answer in that case is always undefined. All right, number 7. This is like number 7 in your math lab. Write a point slope equation and a slope intercept equation. So I just wanted to go over a problem like this with you. when they tell you that your x-intercept is -1/3 and y-intercept is 5. So in your previous video, I told you that you always need two things to write an equation. You need a point and a slope. We've definitely got a point. They tell us that my x-intercept is -1/3, 0, and they tell me that my y-intercept is 0, 5. So if you put them in ordered pair form, that's what they look like. What we don't have is a slope. So I need a slope. Plug into the slope formula. So we have 5 minus 0. And then on the bottom, we have 0 minus -1/3. And that comes out to 5 on top over +1/3 on the bottom. Recall that when you are dividing by fractions, you take the bottom and flip. So I leave 5 on the top. Remember, we change division to multiplication, and then I flip what's on the bottom. So 5 times 3/1, and then multiply straight across, so that becomes 15. So there's my slope. But that's my slope. But in order to write it in point slope equation, so here's what you have in point slope. I told you this is the easiest. You simply take any point on the line. So I'm going to use 0, 5. I don't like dealing with fractions unless I have to. So I'm going to use 0, 5, and I just found that my slope is 15. So I'm going to plug this in for x1. I'm going to plug this in for y1. And 15 is getting plugged in for my slope. And that's point slope form. Okay, the next form it asked me to leave it in is slope intercept. So for slope intercept, I just simply take the point slope form and keep simplifying it. So I have y minus 5. And I'm going to go ahead and distribute 15. So y minus 5 equals 15x, and then 15 times 0 becomes 0. Now, in order to put it in point slope form, your y has to be solved for. So I'm going to add 5 to the other side, and now it is in y equals mx plus b form. Okay, the next two are like 8 and 10. I wanted to show you these. They actually make you do a little bit of work. These problems are disguised, but they are actually horizontal and vertical lines, and I wanted to show you how you get that. They ask you to graph 5x minus 35 equals 0. Well, I want you to notice there is no y in this equation, so it only has x. So you should know right off when you see that an equation only has x or it only has y, that is either a horizontal or a vertical line. Let's solve for x. I know this is going to be a vertical line. No, it's vertical. And the reason is it only has an x. Only has x and no y. So when I solve this, I get 5x equals 35, which you can do that in your head. 5 times 7 is 35. 35 minus 35 is 0. But add 35, divide by 5, and you get 7. And then you can sketch. They provide a graph, of course. in MATLAB, but if you sketch it, I'm just going to say 7's down here, and that would be a vertical line through 7. Okay, the next type of equation we're going to solve for y. We know that this is going to be, no, it's horizontal, and the reason is it does not have an x, it only has a y. If we solve this for y, we get y is -2, and then to sketch it or graph it, it's going to be through the y-axis at -2. I wanted to show you an equation like number 9 that has asked you to rewrite this equation. This is general form, by the way. Notice that it's set equal to 0. So they want you to convert to slope-intercept and graph it. I'm going to first actually show you how to graph this using, we're going to graph using intercepts, but you can graph it after you convert it to slope-intercept if you want to. So if I find my x-intercept, then you take your x term, which is 5x, and then I'm going to add 30. So this becomes 5x plus 6y equals 30, and set it equal to 30. So you're plugging in 0 for y is what you're doing. So x is 6. And then your y-intercept, take 6y, also set it equal to 30, so y is 5. We'll have a point there at 6 on the x-axis, a point at 5 on the y, and then connect them. Okay, for the next part, converting this to slope-intercept, we've already added 30, so let's start from here, and we're going to solve this for y. So we have 6y, let's subtract 5x, and then we have to divide through, I'm going to put my x term here in the front, so we have to divide through by 6, so plus 30 divided by 6. And that simplifies to -5/6 x plus 5. Okay, number 11. Find the value of y through the points that has an indicated slope. In this case, you just simply plug in to your point, plug into slope formula. That's x2, y2, this is x1, y1. I plug in y2, y1 over x2 minus x1, and we get 2 minus y over -1. If you want to go ahead and divide -1 into 2, and get -2 and divide -1 into that. Okay, but they tell you that this is your slope is -3. So what you do is you take this and you set it equal to that. So plug in your points into your slope formula and set it equal to -3. And then solve for y. So when you add 2 to -3, y is -1. On number 12, I'm not going to work through that one completely with you. They tell you that your x-intercept, well, never mind, I'll go ahead. They tell you that your x-intercept is -6. And you know that to find your x-intercept, you take your x term and I'm going to go ahead and add 30. So this will be set equal to +30, and I'll set it equal to 30. And I know that my x-intercept is -6. So you have to think x 30 divided by what is -6? And that would be -5. And then also do the same thing with your y term. Take your y term and set it equal to 30. And then think 30 divided by what gives me 15. So that would be 2. Okay, for the last part, in section 1.5, they discuss average rate of change. Average rate of change is very important, plays an important part in calculus. Calculus actually is the study of the average rate of change all over. So this notation, try not to let it confuse you and overwhelm you, because average rate of change is simply another name for slope. That's all you're doing, is finding the slope of a line between any 2 points. Okay, and where average rate of change typically comes in, when a graph of a function is not a straight line, so for example, if you look here, it says if the graph of a function is not a straight line, the average rate of change or slope between any 2 points is the slope of the line containing the 2 points. So here we see height at age 5, 10, 15, 20. And of course, the height in inches is y. Age, time is independent. But this graph is obviously not linear. But I can find the average rate of change between any 2 points on this graph. It shows the graph of a man's height in inches as a function of his age in years. So we have 2 points that they show you as labeled on this graph, 18, 76. What this ordered pair indicates is that 18 years of age, since that's your x-axis, his height was 76 inches. And when he was 13 years of age, his height was 57 inches. So when you're dealing with these word problems, always take note of what your x-axis and x-coordinates units are, and what your y-axis and y-coordinates units are, what they're talking about. Okay, so to show you that, now let's talk about the mathematical definition behind it. So the definition of average rate of change says if I've got some graph that's not linear, such as the blue graph y equals f of x, some function, and I know 2 ordered pairs that are on that blue graph, they have some x1 and some y coordinate associated with that. All x1 and f of x1 mean is just simply that's your first point, x and y. That's all it means. Then you've got some other point along the graph, x2, and the y associated with it, f of x2. when you find the average rate of change between those 2 points, you're actually finding the slope of the secant line. You'll hear secant line in calculus. And this is the way they put it. Of course, you know, if I have any 2 ordered pairs and I want to find the slope, I simply plug in the slope formula, y2 minus y1 and x2 minus x1. And that can also be indicated as delta y over delta x, which simply means change in your y's and change in your x's. Well, when you subtract your y's and subtract your x's, that's exactly what you're finding. You're finding the change in those y coordinates, change in the x coordinates. This is your formula to find the average rate of change between any 2 ordered pairs. Sometimes they may not just boldly give you the actual y coordinate and you have to do work, which is where this formula comes into play. You will be given your x values. You're going to have to plug in to get your corresponding y with that x and get your corresponding y with this x. But you're still doing the same thing you've always done. You're going to subtract your y's and your x's on top and bottom respectively and in the same order. In a minute, we're actually going to look at how to find the average rate of change or average velocity using a very similar formula. We're doing the same thing, except for they say the average, the change in your displacement or position, which would be also associated with y, and the change in time, which is also associated with x. Anyway, you're still doing the same thing. These are your y's, these are your x's, subtracting y's, subtracting x's. I know it doesn't look very nice anyway. Okay, so to find the average rate of change, these are your steps that I come up with to help you. You plug in the x values or the time values they give you into the function to get your y or f of x values. Or we can also say to get your s of t values. Then you're going to subtract y2 minus y1 or your f of x2 minus f of x1. Or if you're dealing with velocity, you're subtract any of those 3, which really all mean the same thing, on top. So whatever you get at number 1, when you plug in, you're going to subtract those 2 values on the top. You're going to subtract x2 minus x1 or your time values on the bottom. Then all you're going to do is plug in to your formula. So plug in your x values to get whatever your y's are. Pretty much doing the same thing as slope formula, or you are doing the same thing. Subtract your y's on top, subtract x's on bottom, and divide. If they ask you to leave your answer as a fraction, or leave as a fraction depending on what your directions specify, or they may ask you to go ahead and divide and round. All right, we're going to look at the average rate of change of the function and word problems associated with it. So really quick, when you're doing word problems, it's going to ask you to describe what the values you obtained or describe what the average rate of change means in relation to your problem. And so what you simply do, you take whatever units describe x and whatever units describe y, and that's what you would say. The unit used to express the rate of change of y with respect to x. All right, the first thing we're going to do is start off with some basic examples of how to find the average rate of change. And these are actually come from your textbook. In exercises 16 and 17, find the average rate of change, which your formula, recall, is f of x2 minus f of x1 over x2 minus x1. And I told you that you will always be given your x's. So we definitely have the bottom taken care of. But I don't know what f of x2, which is 6, is. So we know this function. This is our function that they give us. And I'm asked to find f of x2. So when we plug in, x2 is 6. So I've got f of 6 minus x1 was 3 all over 6, which is x2 minus x1 of 3. The bottom we can easily see, but the top, we don't know what f of 6 is. So to find f of 6, I have to plug in. So f of 6 is equal to 6 squared minus 2 times 6. That's 36 minus 12, 24. I have to plug in to find f of 3. F of 3 is 3 squared minus 2 times 3. So f of 3 squared, 9, 9 minus 6. So f of 3 is 3. So then I take those values and I plug back in. So now that I know that f of 6 is 24, I've got f of 6 is 24 minus f of 3, which is 3, all over 3. And then, of course, simplify that as far as you can. 24, that's going to become 21 divided by 3, 7. So 7 is your average rate of change. This graph is actually a parabola. And if we take these two ordered pairs, 3, 24, now this would actually be 6, 24. And if we take this ordered pair, 3, 3, and draw a secant line between them and find the slope, it would actually be positive 7. Okay, the next thing in number 17. This is our function. So if we go through our steps, I told you to take your x values and plug in, which is what we just did here. This was step 1. But I'll go through them. I think that might help you a little bit better. Step 1, plug in x's. So I have f of x2, and x2 is 9. So that equals the square root of 9, which is 3. So I just took 9, found what f of x2 or f of 9 is. Let's do the same thing with 4. So f of x1, which is f of 4, and we're taking 4 and plugging in. So square root of 4, 2. Okay, next step. Step 2 is we subtract or plug into our formula. So we can say plug into formula. F of x2 minus f of x1 over x2 minus x1. F of x2 is 3. F of x1 is 2. And that minus sign's built in, so be very careful. All over. X2 was 4 and 9. So X2 was 9. X1, 4. And simplify that as far as possible. So we get 1 on top over 5. I'll show you, like this is our answer, but I'm just showing you what this means. So you don't have to graph it. Okay, they're telling me I've got this x value of 4, which I found has a corresponding y value of 2, because think about it, if I plug in 4 into that, I'm going to get 2. So I got an order pair of 4, 2. That's all you're doing right here. You're just finding out what your order pair is, what your y is. And then I've got this order pair. There's 4, 5, 6, 7, 8, 9. 9, and then of course the square root of 9 was 3. And square root graph starts here. So this is your graph. It's obviously not linear. And they're actually wanting me to find the slope of the line that goes through those 2 points. So that's what you just did. That was your secant line. And I want you to notice, look, that rise is only 1 and the run's 5. So that definitely looks correct. We rise 1, run 5. Okay, the next thing that is also finding the average rate of change, it's just a different type of problem, is dealing with velocity and an object's position versus time. And suppose that the function expresses an object's position, and they always let position be s of t. So position is s of t. Where is the ball at after it's rolled down a ramp 3 seconds later? Time is t. It can be expressed in minutes, years, seconds. So the average velocity of the object from time 1, time 2 is represented. So they give the change in position divided by the change in time. So T1 represents your starting time. Let's say you have an instance where it says a ball is thrown and 3 seconds later, what would its position be? So time 1, starting time, time 2 is the time that it's ending, or you're wanting to find that average velocity period m. And the top gives the horizontal displacement, or change of position. All right, we're going to look at 2 examples, or we're going to look at one. I'll do number 20 with you, and we'll do several parts. You have a problem in math lab just like this. In exercise 1920, suppose a ball is rolling down a ramp. The distance traveled by the ball is given by the function in each exercise, where t is time in seconds. Going back to when we talked about how to describe it, and I told you to pay attention to what your 2 units are. Time is in seconds after the ball is released. S of t is measured in feet. So you're dealing with feet per second, or feet in seconds. For each given function, find the ball's average velocity, which will definitely be so many feet per however many seconds. Okay, and this is our function. And let's look at part A. Part A, we have time 1 is 3 seconds. Time 2 is 4 seconds. Going back to the steps, that I told you on how to find average velocity or average rate of change. So step 1 is plug in. Plug in your t values, your x values into your function. So we're going to find s of t2 and s of t1. Okay, t2 is 4, t1 was 3. But we've got to plug it in to 12t squared. So all you're doing is taking these two time values they give you, and I'm plugging into this to see what I get out. Make sure that you square before you multiply. So this is 16 times 12. Which gives you 192. And this is 9 times 12, which gives you 108. Okay, now that I know what s of t2, s of t1 are, and I have those values, then my next step is simply to plug in. So step 2 is plug into formula. And in this case, since we're dealing with average velocity, I'm going to plug into this formula, which is the exact same formula, except for this deals with s and t instead of x and y. I've got these two values subtracted on the top, so 192 minus 108. And then t2, which is 4, minus t1, which is 3. And then simplify that. So this is 192 minus 108. (84) divided by 1. What this means in relation to your problem, the top dealt with the position in feet. And they told you that. S of t is measured in feet. And then the bottom is your time in seconds. So this is 84 feet per 1 second that this ball is traveling down this ramp. So 84 feet in 1 second. It's pretty fast. All right, we just did A. All right, I want to show you how to do B, or we'll do D out to the side. Okay, part D, they tell you that time 1 is 3, time 2 is 3.001. When you plug those in, because we're still going to use 12t squared. So we're using s of t is 12t squared. When I take and find s of 3.001, 12 times 3.01 squared, that is 108.07. I would wait until the very end to round to the 10th, so keep at least 2 or 3 decimal places. And when we plug in s of 3, we already did that. Over here, s of 3 into that function gave us 108. But I'll show you how. Okay, now remember we're plugging into s of t2 minus s of t1 over that. So you get s of t2, which was here. So that's 108 minus 0.07 minus 108 all over 3.001 minus 3. You can type all of this in at one time because you're going to have to round anyway. So on the top we get 0.07, and that's divided by and when you type in your calculator 0.07 divided by 0.001, that's going to give you 70. So this is approximately 70 feet per second. When you divide like that, when I say 0.07 divided by what's on the bottom, then I'm always understood to be left with 1, like in the denominator. Okay, last one. I wanted to show you, you've got a word problem in Math Lab very similar to this. They give you a graph, and notice that your y-axis, this is actually drug concentration in the blood. Like for example, when you go to the hospital and they give you an injection with so many milliliters of medication. This represents concentration of a drug as a function of time in hours. So notice that time is in hours. So all of your x coordinates represent an hour of time. So 3 hours, 7 hours. Your y-axis is in milligrams per 100 milliliters. So this is 0.01 milligrams per 100 milliliters, and so on. Find the average rate of change in the drug's concentration between 3 and 7 hours, and describe what this means in relation to the problem. They actually give you that your ordered pair at 3 hours, the drug's concentration in your system is 0.05 milligrams per 100 milliliters. 7 hours, 0.02 milligrams per 100 milliliters. To find the average rate of change, you're simply, I want you to notice that you're given your y values. So f of x2 minus f of x1. So I would say 0.02 minus 0.05 over 7 minus 3. And that's going to be negative 0.03 divided by 4. Type that in your calculator. So this is going to give you 0.0075 milligrams per 100 milliliters per hour that it's changing. So describe what that means. And I want you to notice, if we actually draw the secant line through those 2 points and we were to find the slope of that secant line is negative. And so notice that our answer was also negative. Okay. That concludes this lesson. Thank you.